Hey guys, it's day 13 of 100 Days of DSA challenge, and today we have a medium level question, group anagrams. And yesterday I promised that I will solve this question today. I could not solve this question yesterday, and to be honest, this question kind of seemed hard to me. Maybe the toughest one I've solved till date, and I needed a lot of help in this. So, this video is going to be a little long because I want you all to really understand how this works, because I saw a lot of videos on YouTube and they all felt like they were kind of rushing and some concepts were not very well explained. So hence I'm going to explain, I'll try to explain every single thing in this video. So let's start with the problem statement. What does it say? We are given a string strs and we have to group the anagrams together. And what does it say? Anagram is a word or phrase formed by rearranging the letters of a different word or phrase using all the original. Maybe basically. So if there's a word eat, then if I can rearrange the letters in eat, so what can I make? Suppose I can make T from it, from EAT. If I rearrange it, I can make T. So T is an anagram of eat, or I can say eat is an anagram of T, right? So what we have to do is we are given a string and we have to return a string which has groups of anagrams. So bat does not form any anagram in this string, hence it is returned in a group and it's all alone. Then nat and tan, they are anagrams because they can be rearranged, and similarly ate, eat and tea. So one way of doing this question is by sorting and using hash maps, and that was very well explained on YouTube. But it was also mentioned that that approach solves it in n log n, because to sort anything you need n log n time complexity by the default sort function, right? So hence there's a second approach to this which is slightly better, and that is to use an array of 26 letters basically. What our approach is that we will take, like, for each word. Okay, so first I will take a loop, and that loop will go through each word. Okay, so first that loop will be on eat, then it will be on t, then it will be on tan, then eat, etc. and so on. Okay, so now for each iteration in the loop, so for each word basically, for each word we will initialize a vector array of size 26. Now why 26? Because there are 26 letters in the English alphabet, and it is given in the question that the letters can only be lowercase letters, right? So they can only be 26. We know that it can only be from small a to small z. Hence we take the size as 26, which will be from 0 to 25. I hope that much is clear. And what we are going to do is that this is basically our array, let's suppose. Okay, and it is of size 26, and for each letter in the word. Okay, so there will be one loop to iterate through each word, and now there will be another loop to iterate through each letter in the word. So for each letter in the word, we are going to increase the count of the position for it in the array. Basically, uh, it will be of size 26. Okay, our array is of size 26, and initially everything is 0. Okay, initially everything is 0. Just assume that this is of size 26. Okay, from 0 to 25. Now whenever we encounter a letter like E, so what will be the position of E in this? Okay, I know A will be here. Yeah, wait. I know A will be here, B, C, D, E, and this is index 0, 1, 2, 3, 4. So basically E will be at index 4. I know that. So I will just increase the position of E's, and its value will be now 1. Okay, I will just increase the value. And for A similarly the value will be increased. It will be 1. For T, the value will be increased wherever T will be. It will be 1. And similarly, if there was another T, let's say at the back, then this would become 2. Okay, you get that. It's simple. This much is the simple part. I hope you understand that. Now what we are going to do is we are basically going to check that if two words have the same, we are going to check if two words have the same array, this array. If they have the same array, that means they are anagrams of each other. Why? Because it means that they have equal number of letters, equal number of same letters. So eat and tea will have the exact same array. Why? Because in both of them E occurs one time, A occurs one time, and T occurs one time. Okay. Now, how will we check this if they have the same array? What we can do is we can just convert it into a string. Like if this is 0 1, like okay, 0 0 0 0, and for E it will be 1, then 0 0, and for A it was also 1, right, in the beginning, 1 and 0 0, so on so on, and at T it will be 1, then it will be 0 0, so on till Z. Okay. This can be taken as a unique ID, and we can check if two words have the same unique ID. It means that they are anagrams of each other. But now this approach has a little problem. What is that problem? Let's say that I came across a word which has 11 A's and 1 B. Okay, and there's another word which has 11 B's and 1 A. Now for both of them, the array for A and B will look like 11 1, and it will be 1 11, and like then 0 0 0 0, so on, whatever at the end will be. But my point is that when you convert this into a string and concatenate it, it will be 1 1 1, so on, and it will also be 1 1 1, so on. But now that has a problem, because according to our logic, these two will be anagrams, but we know that these are not anagrams. Therefore, we have to find a solution to this problem. Now, what is that solution? That solution is that we will use hashtags, or you can use a comma or anything else, but you have to make them unique. So what I'll do is, when I'm making them into a key, into a unique key, basically when I'm making them into this concatenation, then I'll just add a hashtag after each this element. So now for this particular array where it is 1 0 0 0 1, I will write it as 1 hash 0 hash 0 hash 0 hash 1 hash, and so on. So now the problem which was earlier, which was 11 A's and 1 B's and 1 A 11 B, what will happen in this? Now it will be 11 hash 1, and this will be 1 hash 11, and so on and so on. Now you see, this is how we solve the problem. Now what do we do after this? So now let's just clear the board and understand what we have till now. So what we have till now is that we iterated through each word, and for each word we have the unique ID. For each word we have the unique key till now. Okay, now what are we going to do? So now it's time to take a hash map. Okay, and what is that hash map going to contain? It is going to contain the unique key, which is basically this unique key here, and it will have a value. The value will be the word. Okay, so the word, that is going to be a value. So for example, for eat, it will be like this 1 0 1 hash 0 hash, and so on. It will be in the key. Okay, and in the word it will be eat. But here the word will not contain single element. Okay, it contains a list. Okay, or you can say a vector or an array of elements, because we know that more than one words can have a same key. More than one words can have the same key. That is why they will be anagrams. So this is where we are doing the grouping. Okay, so for example, eat and tea have the same hash, the same key. Okay, so in our table, the key will be the unique key, and the word will be eat, comma, tea. Okay, and if we go further, we know 8 will also be included in this. Okay, and similarly, this for tan there will be a separate key, then that will be added here, and here it will be a list tan, and nat has the same. Okay, so I hope you understood the logic. So this is the unique key. It will be our key in the hash map, and the value in the hash map will be the word. So this is the key, and whose key is it? Okay, got it? So again a recap. We let me clear the board. Okay, we iterated through each word first. Okay, for each word we made a unique key. For each key we pushed it into our hash map, and after that we are simply going to make a result array which we have to return the group. So basically in the result array we will simply uh, push the elements of our hash map, and it is already in the group. Now let's understand the code. Okay, so for strings, and this is basically to call by reference. This is to save memory, because if we don't call by reference and we call by value instead, then it is going to create a copy of s of the strings. Okay, and we do not want that, because that is going to take additional memory. Hence we are using this call by reference. So for string s in strings, so this is basically taking each word. Okay, this statement is iterating through each word. Okay, this big word, this our first loop, as I mentioned. And now vector int frequency 26,0. Okay, so size 26, values initialized by 0, vector. For char c in s. So now we are iterating through each letter of the word. Iterating through each letter of the word. Alright. And what is this frequency? C minus A plus plus. Now what does this mean? Okay. So you must know that in C plus plus or other programming languages, if you write uh, let's say B minus A. So what is this going to return? This is going to return 1, because the difference in the ASCII values of these two is 1. Similarly, in this frequency C, what is C? C is the letter. So for example, in the first iteration, E will be a letter. So E will be the C here. Okay. So E minus A. What will be E minus A? It will be the difference in ASCII values of E minus A. And what will that be? That will be 4. And we discussed earlier that E will be at the position 4. Okay, rewind this part, hear it again, write it on a copy, you will understand it. And I'll just comment, for example, E minus A equals 4. So this is going to store, like this is going to increment the 4th index number, okay, by 1. And now I'm taking an empty string key. Okay, this key is the which contains all the hash and all. And for int I equals 0, I less than 26, because we are now iterating in the frequency array. I plus plus key plus equal to, this means key equal to key plus hash plus toString is to convert our number. Like in our vector array, it is of integer type, right? But we want a string to match. Okay, we are going to concatenate the string. That is why we are converting it to string, and frequency is ith value. All right, and then we are simply pushing back s. S is the string, with like the word. We are pushing the word in the key. Okay, so in the hash map at the key, the word will be pushed. And now this is simply the result. So this is vector, and this vector contains another vector string. Okay, So it is basically a vector of vector. And we know that in the result we need a like an array of arrays, right? So this is an array, and array contains arrays. That is why our result is a vector which contains multiple vectors. And for auto, now what is this auto keyword? Auto keyword is used to, uh, if we use auto keyword, we do not need to define the data type. The compiler automatically takes up the data type. So if we are taking a hash map, right? Hash map has two values, key and values. So hash map will be converted into pair, okay, by this auto keyword. So it will automatically detect that this is a hash map, okay. Now I'll just convert it to pair so that you can easily access it. And I have taken entry like for each entry in the hash map, which is the groups, okay. Result push back. So basically in the result vector we are pushing back entries second. Now entry is the like particular place where we are at the hash map, and dot second. So I told you it's a pair now. So dot second means the second value, which is key comma value. So it will be value. Okay, so we know that in hash map it is stored as key comma value, and now it is as a pair. So if I access the second one, it will access the value. So we are basically pushing back the value. And what is the value in the hash map? If you remember, it is the word. The word is the value and the key is the unique key. And then we simply return the result. I'm sorry if this video was long, but I really hope that you understood this explanation, because it did take me a long time to solve this, but I'm glad I worked on it and I did not give up, and I hope you all don't give up too. So see you on day 14.